Today we're continuing with Core Practical 12, which, if you remember, was investigating the effect of temperature on enzyme activity. Just to remind you briefly, the experiment meant that you had some potato mashed up with some hydrogen peroxide, and you were collecting the oxygen that was produced in that reaction. You were doing that using that burette, and the oxygen produced was displacing the water, and that's what we were measuring. So today we will be looking to calculate Q10 for this reaction, and you will also be doing your write-up for the practical as well. Now I know that you collected some results for me, and all of you did one specific temperature. What I'm going to do is I'm going to give you some class results instead to use. Okay, so this is a rate of reaction calculated in milliliters of oxygen produced per second, and it's given in standard form. The first step for you to do is to use that to draw a graph and stick it into your lab books. Okay, so you've got the temperature, which was our independent variable, so that should go on the x-axis, and the rate of reaction in milliliters per second, which is our dependent variable, and that goes on the y-axis. So if you stop the video here and draw the graph first of all, it should be a line graph with all the dots connected with a straight line. Do not forget your title and your axis labels. Once you have done that, we can move on to calculating Q10. Now, you have now plotted the temperature versus rate of reaction, and from this we should be able to calculate the Q10 for the reaction. There is an equation for this, and that is Q10 is the rate of reaction at a specific temperature plus 10 degrees divided by the rate of reaction at temperature. I know that sounds confusing, but I will show you an example in a minute. Usually we expect a Q10 value of about 2, and that tells us that the rate of reaction doubles in a 10-degree rise in temperature. The actual definition of Q10 is that it is a measure of the difference in the rate of an enzyme-controlled reaction as a consequence of temperature changing by 10 degrees. And this is mostly true for temperatures below optimum temperature. And I'll show you an example. Let's imagine that we've got temperature of 12. Okay? That would go at the bottom. That's a chosen specific temperature. We then need to put the rate of reaction at that temperature, but plus 10 degrees. And so that temperature plus 10 degrees would have given us 22 arbitrary units. That goes on top. We divide it by the 12, and that gives us a Q10 of 1.83. That means that for a 10-degree rise in temperature, the enzyme produced 1.83 times as much product in the same time. Now Q10 does not have any units. Let's have a look at that on a graph. This is an exam question that's asking you to calculate Q10 as the temperature increases from 20 to 30. Okay, so this is our temperature, and this is our temperature plus 10. Just to remind you, Q10 is a measure of the difference in the rate of enzyme-controlled reaction as a consequence of changing the temperature by 10. So we start off with our chosen temperature. If we read that off the graph, that should give us about 13. That's the rate at 20 degrees. Now the rate at 20 degrees plus 10 is about 24. Whatever the rate of reaction is at the higher temperature goes on top, and we divide that by the rate of reaction at 20, and in this case it gave us 1.85, which tells us that by changing the temperature by 10 degrees we have now almost doubled the rate of reaction. Now you can try this yourself by using this graph. What I would like you to do is stop the video and try to figure out the Q10 for each of these. I will do the first one with you just to remind you how to do it. Okay, so we need the rate of reaction at a certain temperature plus 10 divided by that temperature. So it will always give you the temperatures you need to know. Question 1 is the Q10 between 0 and 10. Okay, so this is 0. That gives me 1. And then the plus 10 is 10, and that's a 2. That goes on top, so 2 goes on top divided by the 1. It gives me the Q10 of 2. That means that by increasing the rate of reaction by 10 degrees, I've doubled the rate of reaction. I'm going to do the second one with you as well, and then you do the last three. So, between 10 and 20 degrees, we already know 10 degrees was 2, but the plus 10 is 4. 20 is the plus 10, so that goes on top, divided by 2, gives us 2 again. Again, we have double the rate of reaction. As long as the Q10 is above 1, you know that the rate of reaction is increasing. If it is 1, it means it's staying the same. It's the same as saying 2 divided by 2 is 1. That means that the rate of reaction hadn't changed. If it goes below 1, it shows you that the rate of reaction starts to decrease, which is what you should start seeing as you go through the graph here. So if you stop the video now and try to do the next 3 Q10s, and the answers for those are between 20 and 30, it's 8 divided by 4 to give you 2. Again, we have double the rate of reaction. But between 30 and 40, you can see that the rate of reaction starts to increase. Now, so far, we've had the bigger number go on the top. That's not always the case. Whatever the rate of reaction is at the higher temperature goes on top. So in this case, it's 6 divided by 8, and that gives us 0.75. The rate of reaction is decreasing. We'll repeat that here. Whatever the rate of reaction is at the higher temperature divided by the lower temperature. In this case, 2 divided by 1 is 0.33. This question was actually one of the exam questions in one of the recent exams. And actually, for this one marker, they asked you to do the Q10 between 20 and 30. And interestingly, they would not award this mark unless you have working. So just given 2 as the answer would not have given you this mark. You have to say what you've done. So you have to show that you've done 8 divided by 4 to give 2. Now you can use that information to try to calculate Q10 for your own practical if you do it between 20 and 30 degrees, just like the exam question has done. And then you need to do your conclusion and evaluation, just like you usually do for any practical. Okay, so explain any trends that you see. So what is happening to the rate of reaction as we increase the temperature? What does that mean for enzymes? Comment on any errors that you might have seen, and evaluate your apparatus and method. So did we make sure it was a reliable experiment? Was it valid? If it wasn't, what could we have done? Look over your past practicals to try to see what sorts of things you could put, and you can also use the internet to help you. To check that you have understood Q10, I'm going to put this exam question up on Moodle, and I would like you to answer it for me and submit it to a Moodle link that I will also have up. So this question, rather than a graph, shows you a table. You're asked to calculate Q10 for the reaction between 20 and 30 degrees. So those are the 2 numbers you should be focusing on. Just remember which one goes on the top and which one goes on the bottom. Now we're looking at yeast cells particularly. The substrate again is hydrogen peroxide. A suspension of yeast cells was added to hydrogen peroxide. This is because just like we use potato, yeast cells will contain catalase, which is the enzyme needed to hydrolyze hydrogen peroxide into water and oxygen. The volume of oxygen produced during the initial 2 minutes was recorded, and this was repeated at a range of temperatures. That's what you use to calculate your Q10. And after that, you will be explaining the effects of the temperature increase from 20 to 30 degrees. So whatever your Q10 value was, you can try to now explain why is the Q10 that value. So if the rate of reaction is increasing, what is happening to the enzymes? Why is the rate of reaction increasing? There are 3 marks available for this. And the final question is, explain what happens to Q10 between 40 and 50 degrees. So again, you will need to calculate the Q10 and then explain what is happening to the rate of reaction. Is it increasing? Is it decreasing? And explain why. What is happening to the enzyme? If you could submit this by 4:30 on Moodle, that'd be great. Thank you.